Ryan from Bowlen Development here, and today let's talk about converting primitive data types from one type to another. So if you look at my IDE, an IDE just means Integrated Development Environment. If you don't know what that means, it's the software that I'm using here. I use IntelliJ, and an IDE is essentially just a software product that bundles all the tools together that I need to code Java, right? So if you look in my IDE, you're going to see that I've typed out each of our primitive data types that are numbers, and I've stacked them starting with the float numbers, double and float, and then the integer numbers, long, int, short, and byte. And the reason that I've done this is because this is the precedent that they take. This is the order, the hierarchy that they are in when it comes to casting and widening operations. And I'm going to tell you what that means in just a second. First, I want to give you an example of an error that you might run into that you might scratch your head a little bit if you don't understand what's going on behind the scenes in Java. So if you look at declaration that I've got here, I'm using commas to basically declare three variables at one time. You can do that. I've said, give me, take the short data type and create me three variables. A first number, that's 5, a second number, that's 10, and a third number I'm going to leave undeclared. And the reason that I'm leaving it undeclared is because I'm going to declare it to store the sum of first number and second number. So if I type that out and I say third number should be set to the value of first number plus second number, you're going to see that I get this error. And I can hover over it. You can't see my error message right now, but it basically says the required type was a short and you've provided an integer. But you might look at the screen and go, no, there's really no mention of an integer anywhere. In this comment, but that's commented out. This has happened because Java will always err on the side of saving your data. It will always try to expand mathematical operations into a larger container when doing arithmetic. So in this case, it's taken first number and second number and converted them temporarily into integers. And then it's done the math, which should be 15, and gone to store this in third number, but looked and said, well, that's a short. These are now integer numbers. So you may go, well, then how do I ever use short to do math? I'm going to show you that. This is what we call casting, right? And casting is essentially a way for me to communicate with Java and say, I really do mean to do this, and I want you to convert the data type back to a short so that I can use a short. Think in a case where maybe you're using really small numbers and you're going to do a ton of transactions and you don't want to use up a bunch of system memory just to do those tons of calculations when a byte would be sufficient. You're like, I don't want to use an integer. A byte works just fine. Then great, let's use it. The way that you would cast is you would open up parentheses and you would put the data type that you want to cast. Now, because we have two numbers here that are both integers, we're also going to have to wrap the entirety of the equation into parentheses as well, and you see that our error goes away. And it's because here it's understood, okay, you want to add these two numbers together, take the sum of them, convert them to a short, and store them in the variable named third number, right? So that's a great example of how here when we did math, we were using a short, but Java didn't know if our two numbers that we were going to add together were going to fit into a short. So to be careful, it just converted them up. It widened them, right? So I told you about casting, where I tell Java specifically I want to do this. And then we talked about widening, which is where Java took one data type and expanded it into the higher up data type to give it room and make sure that we don't run into an error where we're overflowing our container and losing some of our data. Think about why that might be important. If you're working on an application that has to do with people's grades or their money, you always want that reassurance to know that if you do a mathematical operation, Java's going to work with you to try and keep your data preserved and not just let it essentially disappear in the system. Because if it didn't throw an error and you just had a mathematical operation that was doing the wrong thing, you then have a logical error and it becomes much harder to trace down, right? So today's lesson is simple, but it's very important. And I've typed out some just kind of from my head definitions of what widening and casting are. You'll sometimes hear these called widening and narrowing. They're the same thing, but widening is when a data type is being extended into or being expanded into a larger data type to accommodate its size, right? And we said that Java does that to protect us from cutting out data, from losing data, or from causing any type of overflow issue with that data type. Casting is going to be when we explicitly tell Java that we want to convert one type of data into another. Again, simple lesson, really important stuff. Thank you so much for being here. You could have been anywhere and you were here, and that means a ton to me. Please throw me a subscribe, and I'll see you in the next video.